This is a multi-parameter instrument, and we are detecting with it pH value and temperature, electrical conductivity or dissolved oxygen in the water. And all these values have to be taken during sampling, and they are absolutely required for the chemical analysis and the correct interpretation of them afterwards. We are researching within an investigators team the groundwater resources in Germany. That means the quantity, but also the quality, and how these groundwater resources develop in future, because we are facing strong climatic but also societal changes, and water abstraction may change tremendously due to climate change. So it's really important that we get a fundamental knowledge about the amount and the development of what we have in the subsurface. So actually someone is thinking probably, so it rains, water is infiltrating into the soil and parts of it eventually becomes groundwater, but the amount is still unknown. So there are a lot of attempts to calculate it, but in the end we are still not really able to get a good answer on that question on a, let's say, aquifer scale. Before I started investigating these groundwater resources here in Germany, I was about 2 decades working in the Middle East, which is a really dry, water-scarce area and also data-scarce area. And there we investigated, of course, groundwater resources and their interaction with surface water bodies and results. Some of the results were really important and found ways to the decision makers, and this made me really happy. Scientists are not always right, but they communicate to the best of their knowledge their findings. And society is not in general against scientific results, but I believe that it's often very difficult to follow the points we are communicating because we are still too complicated in our wording. So we should find an ear to the society and to find the right words to explain it easily, that everyone, almost everyone, can understand what we are talking about.